So let's illustrate the principle, the first principle of surveying that always work from whole to part by this diagram. First, we'll establish the precise position of point A, point B, and point C, right? With very high standard of accuracy. Thereafter, this forms a large main framework, right? And these are the control stations, right? Thereafter, we can establish the position of point D, E, and F by relatively lower standard of accuracy. And thereafter, we can plot the small triangle GHI by even still lower standard of accuracy, right? By doing so, what will happen? The errors in the location of the small triangle will be localized and they will not affect the position of the large triangle ABC, right? So this is the first principle of the surveying, always work from whole to part. For example, if we'll follow the reverse process of working from part to whole, what will we do first? We'll first establish the position of G, H and I, right? Then we'll form this triangle. Thereafter, from that, we have to establish the location of point D, point E and point F by measuring the distances DE, EF and FD. And after that, we have to establish the points A, B and C. And it's quite likely that the position of the points A, B, C as obtained by this process will be less accurate than that working from whole to part. Why? Because this is due to the fact that all the surveying instruments are subjected to some errors and there is always some error in plotting and extension of lines, right? Surveying instruments are subjected to errors and there is always error in plotting and extension of lines. Right? So this must always be noted that for accurate survey, the distance between the control points of the main framework should be as large as possible and the control point should involve minimal possible number of measurements. Minimum possible number of measurements, right? And the control point should involve minimum possible number of measurements and they should be located with a very high standard of accuracy. That's why they are known as control points. And the measurements of a subsidiary framework can be established by relatively less accurate surveys, right? So this was about the first principle of surveying. That is, we have to always work from whole to part, and by doing so, the errors are localized and the accumulation of errors is controlled, right? Let's study about the second principle of the surveying, which is always choose the method of survey that is most suitable for the purpose. Always choose the method of survey that is most suitable for the purpose, right? That is most suitable for the purpose, right? That's about the next principle of surveying, that always choose the method of survey that is most suitable for the purpose. See, any desired accuracy can be attained in the field using modern methods of surveying. But as the cost of surveying will go on increasing, the high accuracy will necessarily involve what? Use of costly instruments. Let me write it down for you. Any desired accuracy can be attained in the field, but as the accuracy will go on increasing, the cost will increase automatically and very costly and precise instruments will be used. Right? In addition to this, more field work needs to be done. and more extensive computations need to be done as well. Right? So with the increase in accuracy, the cost of surveying will increase rapidly. So we have to always choose the method of survey so that the desired accuracy is achieved at a minimum cost. Right? We have to choose the method of survey so that we will achieve desired accuracy, and that too at minimum cost. Desired accuracy should be achieved, and that too at the minimum cost. Right? See, if the standard of accuracy achieved is less than the specified, the results will be useless. So that is also to be taken care of. If the standard of accuracy achieved is less, the results will be useless. And on the other hand, if the accuracy attained is more than the specified, it would lead to wastage of time, money, and effort. So in the interest of speed and economy, a surveyor should always work as close to the required accuracy as possible. Right? So this forms the second principle of surveying, that is always choose the method of surveying that is most suitable for the purpose. But this must also be noted by the students that the relative standard of accuracy of the linear and the angular measurement should be, however, consistent. Linear measurements and the angular measurements. Right? Their standard should be consistent. It's not like you will take linear measurements more accurately and angular measurements less accurately. No. In any survey, their relative standard of accuracy should be consistent. This must be noted. Right? So this was about the second principle of surveying. Always choose the method of survey that is most suitable for the purpose. Moving on, let's study about the third principle of surveying, which is always make provisions of adequate checks. Right? See, there is always a possibility of making errors while taking the measurement, while recording the observations and computing and plotting the results, right? But the survey should be conducted in such a manner that the errors do not pass undetected. Right? And as far as possible, the survey work should be self-checking. Right? Survey work should be self-checking, and we must conduct a survey in such a manner that errors do not pass undetected. That is, we must always make provision of adequate checks. Let me illustrate this with the help of an example as well, diagram. This is the third principle of the survey. Always make provision of adequate checks. Right? We have taken 3 points A, B and C. But the position of the first 2 points B and C is already fixed, and that's known, right? The position of the point B and the point C is fixed, and that is known to us. What we have to do? We have to locate the point A. Here in this case, the position of the points B and C are fixed, and we have to plot the position of the point A, right? See, we can do this by measuring the distance AB and AC in the field, right? And this triangle ABC can still be plotted even if an error is made in the measuring distance of AB and AC, right? We can still plot the triangle ABC and we can still fix the position of point A even if there is a mistake or an error in measuring distance AB and AC. But if we'll also measure the distance AD, this will serve as a check line. How? If the plotted distance AD on the plan does not correspond to the measured distance in the field, error will be revealed. Error will be revealed if the measured distance AD in the field does not correspond to the plotted distance on the plan, right? So in good surveys, the method of taking observations, recording and computations are so designed that the errors are revealed in the process. All measurements should be checked at the time of recording, and this can be done by adopting a method which automatically reveals mistakes. Choose a method which automatically reveals the mistakes, right? And this can be achieved if one survey party does the measurements in reverse direction, and if different parties take the measurements independently, or if the same party, if there is only one party, what they can do, they can take the measurements in reverse direction. And if there are two parties, the same measurements can be taken independently, right? So the survey must be arranged so that the results are checked by office computation and plotting, right? So this was about the second principle of surveying, that is the third principle of surveying rather, that is always make provision for suitable checks. And this can be achieved if different parties take measurements independently or the same party takes measurements in the reverse direction. We must ensure that the survey work is self-checking. Let's move on to survey principle number 4. The fourth and the last principle of surveying is always record field data carefully. Always record field data carefully, right? See, all the measurements taken in the field must be recorded in a proper field book at the time of measurements. We have to always record the measurements in a proper field book, right? Right? And the record must be in a standard form, and this must be clearly written. And this record may be in the form of tables. It can be in the form of sketches or description or all of the above, right? The field record. And this must be noted in a proper field book at the time of measurement, and nothing should be left to memory. Nothing should be left to memory, and we must properly record all the measurements in field book, and we can measure it, we can record it in the form of tables, in the form of sketches or description or all of the above, right? The entries in the field book should be preferably made with a fine black ballpoint pen to ensure permanency, or alternatively we can use a hard pencil 3H or 4H so that a permanent impression is left on the paper, right? Let me write down it for you. To ensure permanency, we must record the entries in the field book by using a black ballpoint pen or alternatively we can make the entries by using a hard pencil 3H or 4H so that a permanent impression is left on the paper, right? See, if there is a mistake in making an entry, a line should be drawn to cross it and the nib value should be written above it. For example, if we have to record a measurement of 25.55 meters